Thanks for organizing this webinar. And in microwave photonics, this field is probably already it's quite some time that this field exists. And now the exciting thing is that the photonic integration is getting mature to have a look at it, to have building blocks for microwave photonics also in integrated photonics. LIGENTEC is a chip manufacturing provider where we work in an ecosystem to develop the technology, fabricate the chips, and deliver the dies to the customer, and that is possible from prototype to volume. In the end, the chips will go in volume in modules or systems at the end customer side, and we work very closely with software houses and design houses like VLC Photonics in Spain. And here I took a picture from an article that actually David Marpong together with Jose Capmani wrote, where microwave photonics could be interesting, and especially integrated microwave photonics, because we want to go down in size and power consumption. And the needs are, I took only 4 here. It's high performance filter, low noise microwave generation, optical modulation, and high dynamic range. And I want to tell a bit what silicon nitride can do there, and what we can offer. And here's I want to start this the first slide with a slide that really shows the link between photonics and microwave to produce low noise microwaves with an optical signal. And that was done in a project together with CSCM, with Steve Leconte in Neuchâtel, and EPFL with Tobias Kippenberg's group at EPFL. So we can take, for example, a CW laser, combine that with a very high Q cavity, and this we are able to fabricate, and then you can generate here a so-called frequency comb, what Steve already talked about, and this, when you put that then back to a photodetector, you get a very pure RF signal. And ideally, this RF signal is very pure. And how do we get a very pure RF signal? When the phase noise here, when the phase is locked in this frequency comb, and this we can achieve to a so-called soliton regime, where you tune this CW laser into this high cavity and then get a frequency soliton out of that. And that shows really the 2 links, where on the left side we are in the photonics world at 200 terahertz, and on the right side we are down to a few tens to hundreds of gigahertz, and that's the link that we actually make in this microwave photonics. Then we have obviously a few components that are important. That one was mentioned just by Jose. We have thermal tuning elements. And these tuners can be very efficient for silicon nitride, because our silicon nitride is very thick. The mode is entirely confined in the waveguide, and this is why you can bring the heater material very close to it. Also, we have developed the heater material where you can tune a resonance up to 4 nanometers, which is quite a lot in silicon nitride. Other components that we can deliver is true time delays or time delay interferometers, where we have where we get very low loss spirals, for example, or Mach-Zehnders in our platform. And here we can get a meter of delay in silicon nitride on a 5x5 millimeter chip, for example. But we are also aware that silicon nitride is a passive platform, and we need to integrate the best of all worlds together. And here, silicon nitride is actually a nice interposer platform and a nice platform where you couple the active elements very efficiently with good performances. Here, for example, coupling of a laser to a silicon nitride module where we adjust the mode field diameter. We can do bonding, and here one example of a bonded 3.5 die where we did high-speed photodetectors together with a research group in UVA with Andreas Behling. And with this, I come to the end. We can show that photonic integration has a huge potential in terms of size, weight, power, robustness, and cost, where we can integrate optical components to a very small footprint, and we deliver the building blocks and the PICs for that. We have the basics with the high confinement silicon nitride waveguides. We can integrate actives, and we have a full creativity suite where you can choose all kinds of passive components. This I would like to thank Jose, Anna, and EPIC to organize this event.